Hi everyone. Welcome to this week's lab. The content for this week's lab has to do with looking at glacier changes using repeat photography. Repeat photography is a technique or a set of techniques that's been around for a very, very long time, more than a century. And for much of that time, the technique has been qualitative. In other words, take a picture of a place and wait a long time, many years, decades, try to go back to the same place, usually somebody else, take a picture of the same scene and then compare the two photographs. Qualitative analysis is still very important, even if you would prefer to have quantitative results. This kind of approach has been used for all sorts of stuff. It's been used for tracking vegetation change, for looking at the effects of management processes, for example, grazing on vegetation and other environmental controls. It's been used for looking at the changes in stream habitats and dune fields. And for today's purposes, one of its primary, most well-known examples is to use repeat photography to look at changes in glacial environments. And for the lab today, you're going to be looking at two different versions of repeat photography. You're going to be doing a little bit of looking from above, high altitude photography, but most of your time is going to be spending looking at ground photography, repeat ground photography, which is slightly more challenging because you usually don't see things from your eyes in a geometrically simple way. You have some closer objects in the foreground that appear bigger and objects in the background appear smaller, and it can sometimes be a little challenging to make out what is what. But you're good at it. It's what you use every day, and we're just going to do the same thing for photos. Now, in order to help us use these photos to look at changes, we're also going to be using Google Earth to compare the photos to places. And just as an example for how you might do this, I'm going to be looking at one particular glacier, just as an example. And what you're seeing here is an article written by United States Geological Survey scientist Jim O'Connor. And he has been using repeat photography to look at changes in glaciers for a long, long time. And he's going to use, in this article, repeat photography to look at Collier Glacier, which is a glacier on the kind of north end of the Sisters. And so what I'd like to do is I'm going to scroll down this article a little bit, and we're going to first look at the map. Here's North and Middle Sister, and up here on the kind of upper left is one of the glaciers on the Sisters, which is known as Collier Glacier. And we're going to be looking at some pictures taken of Collier Glacier through time. And this article actually has several repeat photos of Collier Glacier. Let's take a look at this one. Here are two views of Collier Glacier. The one on the left is 1910, taken by Clarence Winter, and the one on the right is taken by Jim O'Connor in 2010. And you can automatically see there have been a ton of changes. There have been some geomorphic changes to the ground. You'll notice over here there is some moraine that's missing over here that have been shifted away. But mostly what you see is the difference in the amount of glacial ice in Collier Glacier. So in order to help us get some idea about how these two relate to each other in space, I'm going to open up Google Earth. Here we have Oregon. And the Sisters are this area here, and I'm going to zoom in on them. And Collier Glacier is kind of on the upper left corner. This is North Sister. Here's Collier Glacier. And if you're keen-eyed, you'd notice that on either side, but below Collier Glacier, there are moraines. The glacier used to be much larger. One of the tricks that you should get some practice in this week is manipulating Google Earth imagery so you can see things from different angles. There are two ways to do this. One of them is you have a number of controls in the upper right corner of Google Earth. For example, there's rotate control, like this. If you double click on the N, it'll put it back to north. There are tilt controls. We can tilt up or down. There are move controls. And there are zoom in and zoom out controls. Now, personally, those are just fine. You can use those. They work great. I prefer using the keys on the keyboard. If you hit the Shift key and then use the arrows, you hold the Shift and then use the arrows up or down will move you up or down. Left or right will rotate you around like this. And the mouse wheel will zoom you in or out. And in fact, if we pan down a little bit here, we can see Collier Glacier from below. And this is, of course, using a modern day image, which I think is from last year. Collier Glacier is, well, let's say it's only a remnant of what it used to be. It's much higher up. The terminus of the glacier is way up here. It used to be much, much further down. And it has been retreating very, very rapidly, the terminus of this glacier. This feature in the foreground, this kind of reddish-brown feature, is known as the little brother, I think, or brothers. And if you look at the article we were looking at a minute ago, it says here that little brother is the location where this photograph was taken. And so what I'd like to do, and what you should get comfortable at doing, is given a location, can you kind of move Google Earth around in such a way that the scene you see in Google Earth is pretty close to what you would see in the picture. So for example, if I get to about this location, roughly, it looks fairly similar to, oops, I opened up the wrong picture. It looks fairly similar to the modern picture. This is a picture I just cut this from the article, but it's the same picture. You notice on the picture, here's a little mountaintop here, and there's a arête, or the side of the glacier where the moraine comes down like this. Well, we have the same thing over here in Google Earth. Here is that hill over here, and that arête comes down. Over here on the other side, you see in the picture this kind of bulbous area of glacial ice, and the same thing here in Google Earth. This is the same bulbous area of ice. Now, it's sometimes challenging. The picture here has got a lot of high contrast. It's very bright snow versus dark ground, whereas the Google Earth images is a little bit less contrasty. It's sometimes difficult to separate snow from ice. Like these patches in Google Earth are just snow fields. They're not glacial ice. The glacial ice is kind of all connected to one another. But this is still good enough. And what this means is that we can use Google Earth with these images to make measurements. Now, we can't see the end of the glacier in both of the pictures. Here's the other picture from 1910. Let's make it a little bit bigger. If we compare these two pictures, the ice is coming down in both of the pictures, but in this 1910 image, we don't see the terminus of it. It's below, it's beyond this picture. However, we can see the edge of the ice on the side. You can see the edge here, you can see the edge here. And we could imagine that we could look at Google Earth and look at the picture and basically see, here is a trim line, an area where the ice used to be up here, and it isn't anymore. In 100 years, the ice has gone from being up here down to where it is. We could actually take a pin in Google Earth, and we could move that pin to where the ice used to be that we can see in the picture. And we can have that pin placed, and we could put another pin where this edge of the ice is today. Move that over to the edge of the ice. I'm not being super careful, but good enough. And now we can rotate the image back up so it's vertical. Maybe we can zoom out a little bit. You can get pretty good at these controls after a while. And Now we're looking at it as if we were looking at it from a plane or from satellite, straight down onto the image. And it becomes very easy now to take the measuring tool, the ruler. Let's change it to read in meters and measure how much has the ice, the side of the glacier, shrunk, because it used to be in this position and now it is roughly 227 meters. It has melted back. Now that's on the side, not the front. So even on the side, it has melted back a great deal. Anyway, these techniques of being able to rotate Google Earth around to match a historical image, placing pins so that you can take one feature from an image and put it onto Google Earth and make measurements of it from the image is a very common technique in many different sciences for measuring environmental change. And we're doing the most simple version of it, but it's still quite powerful. And in the lab for this week, you're going to be doing this with a couple, 3 glaciers, different glaciers than what I've shown here, but just as interesting. Thank you very much.